Okay, in this tutorial I'm going to look at another type of reaction. This type of reaction is called a single displacement reaction. So the definition is when one element trades places with another element in a compound. And our example is when we add copper to silver nitrate. So guys, just before I go into this, I'll show you a little video of that example. I've actually got two examples for you for this one. But I've used an analogy, and I think it works quite nicely here too. So before we spoke about a marriage where a metal and a non-metal combine. Well, actually what we've got here is we've got a single metal, so a single guy, and we've got a metal and a non-metal, so this is a couple, a married couple. And unfortunately, a single displacement reaction, unfortunately what happens is when we add these two things, nitrate, she is going to run away with copper and leave silver all on his lonesome. So the single displacement reaction, when I teach this in my class, I give it the nickname, this is the affair. Alright, so this is nitrogen. Alright, so we often use the analogy that metals are like guys and non-metals are like girls. Alright, the guys are always the losers, they lose electrons. Girls are always the winners, they win electrons. The girls always change the end of their name. Traditionally the guy's name goes first. All of those rules. But here, this is it kind of fits with that analogy. So silver and nitrate are together, but nitrate is going to run away as soon as we add copper. She's going to run off with copper, and silver will be left on his own. So let's have a look at that actual reaction. So here what you can see is just a test tube. Just pop a piece of copper wire in there. Some people call this experiment silver whiskers. And I'm adding some silver nitrate. So just topping that up, there we go. And you can see that the wire is much more silver down the bottom there. Especially look at the top end, as I'm adding fluid, you'll see it change from that reddish color, that browny color, to a more silver color. So as I add liquid, you can see it near the top end, you can see it getting more silver rather than that brownish color. I know it's not the clearest video, but you can definitely see it there. You can see at the top it's a lot more silver. Now there's one I prepared earlier. You can see a whole lot of silver forming in the place of where the copper was. So what's happening is the copper is a solid. The silver is actually in solution. So it's reacted with nitrate. It's formed a compound, silver nitrate, and that compound can dissolve in water. However, when we add copper, the silver and the copper swap places so that we get copper nitrate in the solution, in the liquid, and silver comes out as the solid on its own that you can actually see in the tube. Now lots of students ask me, oh, can you make silver this way and make lots of money? Well, unfortunately everybody knows that silver nitrate contains silver. So it's not the cheapest of chemicals, and it's not an effective way to actually make any money. But let's write an equation for this one. So in this reaction, we started with, just change color pen. So we started with some copper, so a piece of copper wire, and we added silver nitrate, AgNO3. Again, if you didn't know the formula for silver nitrate, if you have an ion table handy, look at it. Silver, 1 plus ion, nitrate, NO3, a 1 minus ion. When you put that together, alright, that cancels each other out. It matches perfectly, so we just put AgNO3. Okay, and what happens is nitrate, you know, that cheating woman, she's going to run away with copper. So we get copper nitrate, CuNO3. Alright, now copper forms a 2 plus ion, so we're actually going to need NO3 only forms a 1 minus, so we're actually going to need 2 NO3s. So we put brackets around it and we have 2 lots of that ion. It's a polyatomic ion. It's an ion that's actually made of a small group that are sharing electrons, but collectively that group, they lose an electron to make a 1 minus ion. But copper's 2 plus, nitrate, this polyatomic ion, is only 1 minus, so we need 2 of them to balance that. And what we'll get coming out of solution is silver as an actual solid, as as a metal. And that's what we can see forming there. Okay, so this isn't quite balanced. So again, I say we start with the most complex looking one, and in this case that looks like this. It doesn't actually matter so much what you start with, but always try to leave one of your elements. So here we've got silver as an element, or copper as an element, so just only the one type of atom. Try and leave one of those to the end, because we can fiddle around with that and change the numbers without affecting necessarily the numbers of anything else, which can be useful. So, starting with this one here, how many coppers do we have? Well, I've got one copper here, and I've got one copper over here, so that works so far. Alright, maybe we grab another color. So, nitrates, we're going to treat this as one whole thing. So over here I've got 2 nitrates. Okay, and I can do that because we've got nitrates here and nitrates here. We can just treat it as one group. So that's often true for your polyatomic ions. So NO3 over this side, we've got 2 of them. On this side, we've only got 1 NO3. So what we're going to have to do, we're going to have to add a 2 to the front of my equation, to the front of this formula here. So that's now going to give me, alright, go back to green, now I've got my 2 nitrates, so now those are balanced. So lastly, we need to have a look at silver. So silver here, I've now got 2 silvers right there, 2 lots of silver, so the big 2 of everything. And on this side, oh, I've only got 1 silver, but that can easily be fixed. We just put a big 2 in the front. So 2 silvers, 2 lots of silver, alright, and now I've got 2 silvers on that side. So let's go through and check everything off. 1 copper on this side, yep, 1 copper on that side, 2 lots of silver on this side, alright, 2 lots of silver on that side, that works. On this side, 2 lots of nitrate, NO3, on this side, 2 lots of nitrate, NO3, so yep, that last one works too. So there we've got a balanced equation. Okay, so we're going to look at another example of a single displacement, or another affair. So we'll look at another example of this type of reaction. Oh. Okay, so in this case, you've probably all done this one. It's a fairly simple one. Taking some magnesium ribbon, some strips of magnesium, and putting them in some hydrochloric acid. So adding some hydrochloric acid to the magnesium, and you can see it fizzing away there, fizz, fizz, fizz. Alright, and you can actually, that tells us it's producing a gas, and we can collect this gas by putting our finger over the top of the test tube. So I've turned out the lights, because what we can actually do is light a match, and if we've got our thumb over the top of the test tube, we can collect that gas, and if we light that gas at the neck of the tube, alright, I don't know if you heard that, there's a slight little pop and a slight flash. Sometimes it makes a squeaky pop, so that's hydrogen gas. That's how we can test for hydrogen gas. So when we add magnesium to hydrochloric acid, we get a hydrogen gas being produced. And this is actually a single displacement reaction, and I'll show you why. We'll do this one as an example too. So let's look at what we started with. We started with magnesium metal, and we combined it with hydrochloric acid is HCl. And we know that we had some hydrogen gas produced. I'll put this one over this end. Hydrogen gas is H2. So we've got some of the hydrogen out. Well, what's actually happening is chlorine, so we've got here metal, alright, a metal, magnesium, hydrogen acting kind of like a metal, alright, in this case it's not actually an ion, but chlorine is going to do, like in the last one, chlorine is actually going to run away with magnesium, leaving poor old hydrogen on his own. So chlorine's going to run away with magnesium, so obviously what we're getting here is magnesium chloride. Alright, and before we go any further, looking on my ion table, magnesium is a 2+ ion, makes a 2+ ion, chlorine makes a 1+ ion, a 1- ion, so 2+, 1-, need a little bit more minus there. So there we go, 2 lots of chlorine will make that 2+ and 2 minuses, that cancels out, that balances. So those are the formulas for each of the things. Now we've got to balance the overall equation. So magnesium plus hydrochloric acid, HCl, makes magnesium chloride and H2, hydrogen gas. Okay, so going to balance that equation, we look here, how many magnesiums have I got on this side? Just the one. How many over this side? Just the one. Alright, over here, how many hydrogens do I have in HCl? Well, here I've got one hydrogen, and over on this side I've actually got two. So over here we need to put a big 2 in front, and now I've got 2 hydrogens too, so that works. Okay, so that means now here I've got 2 chlorines, and over here, Cl2, I've got 2 chlorines anyway, so that still works. So go through and check that everything balances. 1 magnesium, so that's fine. Alright, 2 lots of hydrogen. So we've got 2 hydrogens here. H2 is 2 hydrogens on that side. That one works. 2 lots of chlorine. Remember, this is big 2 means 2 of everything. 2 lots of chlorine. That one works. Cl2. Yep. Alright, so the chlorines match up. It's balanced. That's all we need to do. So guys, this is an example of a displacement reaction again. So chlorine, that non-metal here, running away with magnesium in this case, leaving poor old hydrogen on his own. Okay guys, I hope that helped, and we'll look at another type of reaction in the next video.